And now the reason why you're all here for the talks and the food and the raffle, hopefully. So first up is Graham, who's going to be talking about sustainable data management. So if everyone could just welcome Graham to the podium.
Thank you. Thank you. Welcome, everyone. It's nice to see you all. My name is Graham Zabel on the screen. Just get this to work. So up until very recently, I ran our cloud and DevOps practice at a consultancy called Devops. I'm no longer there, but the branding has been whited out. Actually, this is a Devops presentation. But so for 6 years, I was leading their cloud and DevOps practice. So I've spoken at a lot of DevOps meetups, but I've never spoken at a data meetup. So this is a new experience for me. Right. So today I want to talk about data. We're living in an age of data, and that's causing us some problems. We're consuming and creating vast quantities of data, and some of this is manifested in things like data hoarding or dark data, the fear of deleting data, which I'll get into a little bit. The 10x problem. So a lot of the data that I look at in my workings with cloud and DevOps and AI, what I'm seeing is there's 10 times as much data in many cases as we need. And I'll show you some of those anti-patterns. Then talk about storage is free. I used to say storage is cheap, but it's now basically free. And then what we can do to mitigate some of these issues that we have with data. Right, so anyone heard of these books or read these books? Yuval Harari, fantastic books. My son started reading them actually, so I reread them. I've just been on holiday for 2 weeks and I reread them on holiday. And it's interesting, he talks about the history of Homo sapiens as we move from hunter-gatherers to farmers in the agricultural age to the industrial age, which sort of started 200 years ago with the steam engine and Darwin's theory of evolution, et cetera, into what now is the information age, the age of data. Sam Altman wrote a paper on the information age a couple months ago. It's on the web. What's interesting, though, is what he talks about as farmers before the industrial age, we essentially were mostly religious. Life didn't change much, and what you had to look forward to is the afterlife. So we weren't going to change much now. Life would never change, but in the afterlife, things will get better, and everything was God's will. And then we moved to the industrial age, and the theory of evolution comes along. God is dead, says Nietzsche. So we realize there is no afterlife, and we've got to have a good life in the life that we're living now. And if there's no God, then we can do what we want. We have free will. Now we're coming to the information age where through the study of genetics and nanotechnology, we're realizing that actually we are code as well. We are DNA, and maybe that we are essentially organic algorithms, and we work on data as well. So he uses this term dataism as the new paradigm of the age we're in. So the fact that we're in this information age, which is all about data, causes this issue. So the volume of data that we are creating is going up exponentially for all kinds of reasons. AI is obviously a huge one. Streaming, crypto, quantum computing, IoT, et cetera, the data is growing hugely. This graph is measured in zettabytes. Anyone know how much a zettabyte is? 1 million gigabytes. So the 2 on the left-hand side, 2 zettabytes, that's roughly equivalent to all the storage of every mobile device in the world. As 2 zettabytes. We're growing by 20 times that much in the next year, potentially. So this has knock-on effects. To store all this data, we need data centers. Data centers require power, and the power that we need to power these data centers are directly impacting our ability to cut down carbon emissions. So the big hyperscalers, AWS, Google, Microsoft, they will tell you, proudly, we're going to be net zero, where all our data centers are powered by renewable energy. Arguably, they're stealing from Peter to pay Paul. So all this nuclear energy and renewable energy we're building for data centers we should be using to offset oil and gas, but we're not because of the amount of energy required. I mean, everyone is talking about how much energy we're going to need for AI. It's just we're not replacing our oil and gas. We're just building renewables for data centers. So last year, our oil and gas consumption was the highest it's ever been. It's not going down. So what can we do about this? What can we do about this huge amount of data? And I'm looking at many, many systems over my life. One of the things that's really struck me is how much waste there is in our data, how much waste there is in our unstructured data, in our structured data, in our personal data. And can we do something about this waste? And potentially, can we knock off 20% of this storage? I would argue that we can potentially knock off 80% of the data that we're storing, and I'm going to explain why. Okay, this is a picture of an empty warehouse. So if you will, a pictorial representation of a digital warehouse. And if anytime we get a new system, a new database, a new platform, a new tool, we typically start with empty storage. And what happens is it's very easy to put data into these storages, into these warehouses or databases. That's what they're there for. They're there to store data. So it's very easy to get data in. Once data is in any of these kinds of stores, it's very, very hard to delete it. Once it's there, it's pretty much there forever. Why is it hard to delete? Because we have data retention policies. Sometimes we're not allowed to delete data. We have to keep it for 7 years if you're in finance, etc. Often we don't know what's important in these databases. Or data stores. Especially as data ages, as it gets older, we lose track of who owns it, what it was there for, and so it just sits there. Often it's missing tags, labels, which is very important. And then there is FOD, or the fear of deleting data, which is huge. So if in doubt, just leave it there. You cannot get in trouble for leaving data there. If you delete something accidentally, you can get in a lot of trouble. Right, so as a consequence of this, our data stores get bigger and bigger and bigger until they look like the virtual equivalent of this. And this, if you picture in your mind a data lake or data warehouse, often these tools are being managed by third-party vendors. Sometimes they'll come in, they're not incentivized to clean up these stores. These stores don't typically make revenue for companies, so they're under-resourced. So the people that are looking after these databases, these data stores, are just running to keep, to stand still. They're dealing with daily issues. They're dealing with maintenance and upgrades. They don't have time to look at the stuff on the third shelf. And if you look at those boxes on the third shelf, some of them have writing on them, some of them don't. Some of them you can't understand. They've got some numbers, doesn't mean anything. This is very equivalent to what we're doing in virtual data stores. So, how many people have heard of the term dark data? Yeah, it's getting more and more common. Wikipedia says dark data is data which is acquired through various computer network operations, but not used in any manner to drive insights for decision making. A couple other quotes. Some surveys, a recent survey by NTT came out this year, said 60% of organizations' data goes unused. A book published a couple years ago called Worldwide Waste. He claims, the author, that 90% of data is never accessed after 90 days. New York Times, in an article about 5 years ago, said that 90% of the energy used by data centers is wasted. So all dark data is all the stuff on the third shelf of those warehouses. It's the stuff we don't know what to do with. It's the stuff that doesn't have labels or names or ownership, and we just store it. So let's look at some of these anti-patterns that cause this dark data. This is, as I said, I was in South Africa for the last 2 weeks. Wonderful place if you've never been. But anyone know what this is? Picture of a whale, yeah. And I'm being a bit meta. It's a picture of my wife taking a picture of a whale. So, and if you can imagine, there are 40 other people on this boat taking pictures of this whale, and we're all probably taking dozens of pictures. And I get home and start looking at my pictures and go, that really doesn't do justice of the experience of having a whale swimming by your boat. And so I look at this picture, I might look at it twice, and I'll probably never look at it again. And then if you multiply this times the 40 people on the boat, times the 20 pictures that they've taken, there's a lot of data that we just not use. From a personal point of view, this is another example, picture of my family. God bless them, my parents no longer alive, but this was taken about 15 years ago. It's still in there. Really, I only need one of these pictures. I don't need 10. Ideally, I'd have an AI or something to say, pick the one that's got everyone in focus and everyone looking at the camera. But I have not found a tool that does that. I've looked. Most of the tools that clean up your photos require a lot of manual intervention. So we just don't do it. So we still have 10 times as many photos as we need. Okay, so moving on to enterprise data and unstructured data. Early this year, I was working on a AI proof of concept. Anyone here not working on an AI proof of concept? A few of you. Most of us are. So our proof of concept at Devo team was, we've got all of this sales data. Wouldn't it be amazing if you could ask an AI, have we sold any AWS to GCP migrations in the last 5 years? Or have we sold any projects in telecoms in Scandinavia? Those kinds of typical sales questions. And what happens now is I spend a couple hours looking through our G Drive to see if I can find anything. I can't find anything. I'll send a chat message to someone in Scandinavia saying, hey, do you know if we sold any telecoms work? It interrupts this other person. They've got a context switch. Wouldn't it be great if an AI could just answer this question? So we thought, let's do a pre-OC. Let's ingest all of this data into an LLM. Let's RAG this data, and we can get an AI to answer all these great sales questions for us. So we were only doing a proof of concept on the UK data. I worked for a French company. Most of the data's in France. I didn't have admin access. I had admin access to our UK data. So we were doing a proof of concept with this with AWS, Amazon Q. I started looking at the sales drives. Spent a couple of days looking at the data because the ingestion was taking 8 hours. It was costing a fortune. What can we do about this data? So as I started looking at it, I realized, wow, there is a lot of garbage in our G Drive or our OneDrive. And I made a rough finger in the air estimate that probably 50% of the stuff that was in there was not needed. All of this archive stuff. An AI you don't want to put that into your LLM. I started finding copies of, and there were hundreds of copies of. So then I found, well, there's copies of copies of. So we've got copies of files. These stuff doesn't need to go into an AI. Old as well. Anyone seen a file folder in their file system called to be deleted? Yep. To be deleted. They never are, by definition. Right. So here's another example. This is a particular file in a sales drive. 4 different versions, 2 types of format for each version, 9 different files where we probably only need 1. So I thought, what do we do with this problem? How do we sort this out? What we need is a data retention policy. I know this is not easy to read, but I started going through all these sales folders, hundreds of them. I realized there's a common pattern across a lot of them. We have SOWs, statements of work, purchase orders, working at risk requests. So if you want to work before you've got the contract signed, job descriptions, CVs, pricing spreadsheets, resourcing spreadsheets, all kinds of this stuff. And then for each of these documents, we have potentially many versions. We'll have draft versions, incomplete versions, we'll have a completed version, and then a signed PDF, countersigned PDF, et cetera, et cetera. So if you add all this up, there's about 14 documents in here in a typical sales drive. Once the work is completed, yes, you need all this stuff while you're doing the work. Once the work's completed, you only need really these 2 things. You need a countersigned PDF of the purchase order and the statement of work. All this other stuff is redundant. CVs from 2 years ago, job descriptions, they're out of date. They're of no value to an AI. So this is another example of a case where it's an 80% reduction in the amount of data if you have a good data retention policy. Very quick, I'll just go. These are some from an earlier talk I did on Devops anti-patterns. So Devops is all about automation. We take things that we were doing once a week or once a day, like manual testing or manual builds, manual deployments. We automate them, and all of a sudden we're doing this thing every 5 minutes. So these processes are creating log files, test evidence, artifacts, et cetera, and we're getting an explosion of data in the DevOps world. I was talking to someone today who said that they're using New Relic as a monitoring tool, and they've just turned on their automated incident raising. Most of their incidents were raised manually. When they turn on the automated incidents, their incidents went up 50% the next day. So all of a sudden they get this explosion of data. This is what I call a bad data virus. So another project I was working on earlier this year on a CMDB, configuration management database, which is essentially where all your assets are stored, ServiceNow database. In the CMDB, we had a duplicate record. I happen to have admin access to this system. So I thought this duplicate record should not be there. I'm going to delete it. So I deleted it. And in the meantime, they were doing a migration to a new system. So I deleted it. It was gone there. I thought, great. Next day, I come and look at it, and the record's there again. And I did a bit of this digging and found out this is not our source system. We have an upstream system, which is the golden source. So I thought, wow, I've made a discovery here. I'm going to tell everyone that, do you guys realize that this is not our golden source? So we've got an upstream feed feeding data. And it's actually polluting this system, but we also have, it feeds downstream discovery tools. It feeds a data lake, and the data lake's always on highly available architecture, typically across 2 AZs. So when you have a piece of bad data, it's not necessarily in one system. It could be in dozens of different systems. But having done all this, I thought, wow, I've made a great discovery. But in fact, I got a slap on the wrist. I was told, what are you doing with admin access, deleting records in production? You know, and I could have actually lost my job doing this, doing something that I thought was a good thing to do. So another 10x problem. And then finally, again, these are, you know, from a DevOps point of view, DevOps tools. Every time I go into a new company and look at their DevOps tools, no one deletes anything. So if you take Jira, for example, when I was much younger, probably before a lot of you were born, when we had Kanban boards, we used a wall. We used Post-it notes. And we had 3 columns: to do, doing, done. At the end of the done, there was a bin, and we put the Post-it note in the bin. Now in Jira, no one deletes anything ever. So there is got to be a happy medium between the Post-it note in the bin and storing every Jira ticket forever and ever. And I could go on. All these tools are problematic in that respect. I know we're running out of time. So the last thing I want to talk about is this idea of storage is cheap, or in fact, storage is free. This is the pricing sheet for Google Workspace. We were using Google Workspace at Devops. This is an enterprise pricing. We had about 10,000 users. So the enterprise pricing and the Business Plus, you get 5 terabytes per user if you buy into this plan. Microsoft OneDrive will be the same. 5 terabytes per user times 10,000 users is 50,000 terabytes. The average company, large enterprises, use about 500 terabytes of unstructured data. So about 1% of what you're given. So in effect, storage is free. Any extra storage you need is already paid for. So there is no, so it's just, it encourages data hoarding. There's no cost incentive to reduce your data. So when I was doing this AI proof of concept, I realized we had so much garbage data, all the sales data. Let's put in a data retention plan. Let's clean up a lot of this old data. I went to our chief data officer, I went to our CTO, and I said, let's clean up this data. And they basically said, no, there is no incentive. We're not going to save any money. We don't have any resources to do this. It's going to cost us money to try and sort out the problem, and we're not going to save any money. So it was a non-starter. So this idea that storage is free and fear of deleting data are these 2 huge memes that just stop us from deleting anything and having our data going crazy. Excuse me. Right. So we can't say delete. We get in trouble for saying delete. You lose your job if you say delete. So what do we need? We need good data management. And what does that look like? You need senior management buy-in. Of course, if you don't have that, you're not going to get anywhere. Oh, the numbering's wrong. They're all number one. They're all number one. So conduct a data audit. That's kind of obvious. You need a data classification scheme. The really important one for me is the data retention policies. So we're getting really good at GDPR data. We're getting good at customer data about what to do with it, about recycling it, right to be forgotten, all of that stuff. But if you look at a data retention policy for a JIRA ticket, there isn't one. No country has one. No institution has one. You've got to be opinionated. You've got to come up with a policy because you're not going to be told one from anywhere. And we have to be pragmatic about all of our data. Those JIRA tickets, do we need to keep them for 7 years when we used to put them in the bin when we're finished? Probably there's a happy medium somewhere. So we need data retention policies for basically everything. And they just don't exist. The large enterprises will have a very small department, and they're really just focused on customer data. I know I'm out of time, so I think, if we recognize some of these patterns around storage is cheap and fear of deleting data, if we can get over those things, we really could save a lot of cash and carbon and start building renewable energy to take out oil and gas and not to build new data centers. Thank you.
Thank you. We have 5 minutes for questions if anyone has any. No? Oh my God. Yeah. I saw you first.
So AWS says cost is a proxy to carbon, right? So they say if you bring your cost down, you bring your carbon down. What do you think to that?
Thank you. Cost is absolutely a proxy for carbon, and you can see how that backfires, right? If you can't save any money by reducing your storage, you're not going to save any carbon. People don't really care about carbon, they care about money. Yeah. I would say that. I mean, we've talked to Google about this very problem, but essentially storage is free. The pricing plans with it should know, but in their pricing structures, there is zero incentive to save money. And it's the same with us, right? We probably all have iCloud. We pay what, 99p a month? It's nothing, right? We don't even think about the 99p a month. So there's no incentive for us to clean up my 10 photos of my family from 15 years ago because it's 99p. So people will rail against the fact that, oh, if we start pricing for storage. In fact, I think there's something in the EU right now that I think it was Apple just got problems because they're anti-competitive in terms of their storage. You can only use their storage, which is anti-competitive. And ideally, if they opened up the market, you could get it even cheaper than 99p. So we're not going to be deleting our old photos if we're paying 99p a month. It's not going to happen. Sorry. Yeah.
So I'm a little confused. So if cost does map to sustainability and carbon, and storage really is free, it nearly is, right? Why would I spend any time deleting stuff, right? That's going to take me time.
Right.
It might be better take that engineer time.
Yeah.
Spend that on optimizing my compute, which does cost money and does have a carbon footprint. And that, if I'm truly sustainable, wouldn't that be a better place to spend my engineer hours than going on data retention policies and going and trying to find those 9 photos?
Yeah, I have 2 answers to those. So one about the compute, it's actually a lot of, I've had this argument with people, it's the compute that costs money, not the storage. But the compute is potentially a proxy for storage.
If you're not careful,
if your database is half the size, your indexing is going to be quicker, your search is going to be quicker, your CPU is going to be less, etc. So there is definitely a correlation between compute and storage. It's not one-to-one, but it's something. Now the other thing is there's no incentive to delete data because it's cheap. And up until now, I would agree with you. And I think hopefully what now is the game changer is AI. When we were doing this proof of concept, when you're ingesting, 80% of the data you're ingesting is garbage and it gives you hallucinations. So when I ingest 8 copies of the same document, 8 versions, I get crazy answers. And we saw this, so you get a lot of hallucinations because AI doesn't know if it's a copy of, or the copy of, the copy of, or which document I should use. It just brings it all in, and garbage in, garbage out. So if you clean up the garbage, you're going to get much cheaper, faster, better quality AI. And I think, and I hope, that is the game changer that's going to change this idea of storing everything.
Moving on, yeah.
I was just going to say, do you think part of it is the ability to use AI as well to actually get us something that cleans this stuff up faster? Because at the minute, it does feel like a lot of effort when you're asking people to go through and do the textual.
So get AI to clean up your data. Yeah. I think that's problematic as well. But you need some rules. Any kind of system will need rules. What do I need to clean up? And that's where it comes back to the data retention policies. If you can get those in place, then you can automate that cleanup. You don't really need AI. It's just automating cleanup. Get the rules right. Otherwise, an AI, what does it know? How does it know what to clean up? Doesn't. Yeah.
One final question. I think we have one in the back. If you can speak up.
Thanks. Thanks for the talk. So I think have a clean data management is not really cost saving as any purpose. You have a clean data for the better, you can make the data more reusable, because a lot of duplication data will confuse your user. So I think that's a good benefit. But another issue I think is now when you want to clean your data, but your stakeholder, the owner of the data, they have an overwhelming by all the data business questions or model iterative. So how you can convince stakeholder to really cooperate with you to do this data management? Because
I think again it's partly it's going to be AI, but partly I think one of the problems with having all kinds of bad data or garbage data is that you end up coding around it all over the place. There's scripts in Snowflake and Databricks and all these code arounds because of the bad data. And I think the costs are really nefarious and hidden, but real people that really know data understand the effects of this. And hopefully we can find a way to show the real cost of storing all this bad data. But yeah, I mean, that's the $1 million question. Yeah.
One more question.
Okay.
Sure. Hi. Yeah, thanks for the session. As you said, we, as individuals, reluctant to delete the data, and more data means more data centers. And I've recently read, within London, in one of the boroughs, they're using the heat generated from the data center to power or maybe supply that heat to, some 8,000 homes or something. So would you consider these as sustainable initiatives?
Not really. In fact, the opposite is true. There are 3 boroughs in London at the moment. They can no longer build any more houses. House building is frozen because the electricity grid is at capacity because of all the energy that's required by the data centers. The M4 corridor is the second highest concentration of data centers in the world after Virginia. And so there's a massive demand for power in that corridor. And so boroughs in that area now don't have any more electricity to build houses. So I think for me, that's a bit of greenwashing. Let's use the heat from the data center to power the local houses. It's the other way around. They're taking a lot of the electricity that we need for residential. So I think that's greenwashing, to be honest. Sorry.
Thank you.
Yeah, okay.
Thank you, Graham. That's interesting. That's a lot of food for thought.